Hey guys, today we're going to solve some quadratic inequalities. So to do that, the first thing we're going to do is essentially turn that equality into an equation. So instead of having x squared plus 2x minus 8 is greater than or equal to 0, I'm just going to put that as equals 0. Then we're going to solve. So remember, we're looking for two numbers that multiply to negative 8 and add to positive 2. So that's going to be positive 4 and negative 2. Now, since a is 1, we know that we can just go ahead and factor it down to x plus 4, x minus 2. But you can also split the middle term if you'd like. Plus 4x minus 2x minus 8 equals 0. Factor out an x, get an x plus 4. Factor out a negative 2, get an x plus 4. And then we'd end up with the same thing. X plus 4 times x minus 2 equals 0. So whichever way you want to go about it is totally fine. Now, once we're at this step either way, actually let me put that in a different color. Once we're at this step either way, we want to use the zero product property. The zero product property says if two things are multiplying to equal 0, then those two things, one of them at least, is going to be equal to 0. So we'll set both of those guys equal to 0. So we'll end up with x equals negative 4 and x equals positive 2. So the next thing we're going to do is we're going to make a number line. And on that number line, we're going to put the two values we got for our solutions, negative 4 and positive 2. And then we're going to check each interval. So here's what we know already. We have the inequality. Sometimes it's easier to plug in when it's already factored. So we have x plus 4, x minus 2. That's what my x squared plus 2x minus 8 factored down into. And we know that needs to be greater than or equal to 0. So now we're going to test each interval to see which of these make my inequality true. So let's say that over to the left of negative 4, maybe I want to plug in negative 5. So I'll have negative 5 plus 4 times negative 5 minus 2. Is that greater than or equal to 0? Well, negative 5 plus 4 is negative 1. Negative 5 minus 2 is negative 7. And a negative times negative makes positive. So that is greater than or equal to 0. So it's going to be over here. That's part of my solution. Now I'm going to test a part in the middle. The easiest number to plug in between negative 4 and 2 is 0. So let's plug in 0. 0 plus 4 times 0 minus 2. Is that greater than or equal to 0? Well, then that's positive 4 times negative 2 is negative 8. Is that greater than or equal to 0? No. So this spot in the middle is not going to be part of my solution. Then we'll plug in something over here to the right of 2. So maybe we want to plug in, gotta find a different color. Maybe we want to plug in 3. So we'll take 3 plus 4 times 3 minus 2. So 3 plus 4 is 7. 3 minus 2 is 1. 7 times 1 is 7, and that's positive. And a positive number is greater than or equal to 0. So this over here is also going to be part of my solution. So now we're going to write that answer in interval notation. So I have values from negative infinity all the way until negative 4. Oops, hang on. All the way up until negative 4. Now, I have an or equal to right here, right? Sorry, on all of these. So that means we need to have square brackets on -4 and +2 since my inequality is or equal to. So from -infinity till -4, and then I'll put a bracket, square bracket. I don't have anything between -4 and +2, but then I have more values starting off at +2 to infinity. Since I want to put those two sets together, I'm going to put a union in between. Good deal. So let's solve the inequality. So the first thing we need to do is turn this into an equation. Then we're going to factor. First of all, let's look for a GCF. Do we have a GCF? No, we don't. So I'm going to have to multiply my ends. 2 times -12 is -24. And my b value is 5. So what multiplies to be -24 and add to +5? 8 and -3. So since our a value is not 1, we can't just put x plus 8, x minus 3. We're actually going to have to split the middle term. So we'll split that 5x into a positive 8x minus 3x minus 12. Take the greatest common factor of those first two terms. The greatest common factor of 2x squared and 8x is 2x. When I factor it out, I'm going to divide. 2x squared divided by 2x is x, plus 8x divided by 2x is 4. Now we know we want to end up with an x plus 4 over here. So what do I need to factor out of -3x minus 12 to get positive 4x plus 4? Need to factor out a -3, right? So then we'll take out what they have in common, that x plus 4, and then we're just left over with that 2x minus 3. Then once again, we'll use that zero product property and set each of those equal to 0. So x plus 4 equals 0. So x equals -4. That's one of my solutions. 2x minus 3 equals 0. So x equals 3 halves. So that's going to be my other solution. So now that we have those, we're going to put those on our number line. We've got -4. We've got 3 over 2, or 1.5. All right, so we had this factored down into, I'm going to put 2x minus 3 first this time, just because it feels good. No other reason other than that. So we factored that stuff, and we want it to be greater than or equal to 0. Awesome, here we go. So let's plug in something to the left of -4. Like maybe we should plug in -5. So we'll take 2 times -5 minus 3. That's -13, by the way. Times -5 plus 4. And that's -1. -13 times -1 is positive 13. Is positive 13 greater than or equal to 0? Absolutely. So that is going to be part of my solution. Then we're going to plug in something in the middle. The easiest thing to plug in between -4 and 3 halves is going to be 0. So if we take 2 times 0 minus 3, that's -3. And then we'll have 0 plus 4, that's positive 4. -3 times positive 4 is -12. Is -12 greater than or equal to 0? No, it's not, so that's not going to be part of my domain. Then we want to plug in something to the right of 3 halves. So just larger than 3 halves is 2. So we'll take 2 times 2 minus 3. That'll give me 1. And then 2 plus 4 is 6. So 1 times 6 is positive 6. Is positive 6 greater than or equal to 0? Absolutely it is. So that's going to be part of my solution. Now what you actually tell me as the answer is going to be the interval notation of this. First of all, we have greater than or equal to, so we know that these need to be brackets on -4 and positive 3/2. So let's write that interval notation. Starting off way over to the left, we're starting at negative infinity. I'm going to write this in a different color. I'm sorry, guys. We're going to start off at negative infinity. And then we stop having values at -4. It's or equal to, so we have a square bracket. Then we have a little bit of a gap. And then we're starting back off at 3/2. Oopsies. Oopsies. And then I'll have values until infinity. To put those two sets of numbers together, I'm going to put a union in the middle. Good deal. Let's try this one. So now not everything is on the same side, right? So if we turn this into an equation, we're going to end up with 3x squared. I'm going to add that 13x on over because I like to keep my x squareds positive. Plus 13x. And then we'll add that 10 over as well. So we have plus 10. We want that to be greater than or equal to 0 since we brought all that stuff over to the other side. Cool. So now let's start factoring this. Do I have a GCF with 3, 13, and 10? No, I don't. So what I need to do is I need to multiply my ends. I'm going to take 3 times 10, and that's 30. And then my b value is 13. What's two numbers that multiply to 30 and add to 13? 10 and 3, right? So we'll split that 13x into 10x plus 3x. Turn that into an equation. We'll look for our greatest common factor of our first two terms, 3x squared and 10x. My GCF is x. So when we factor out that x, we're left with 3x plus 10. Then we'll look at 3x plus 10. What's the greatest common factor of 3x plus 10 if they don't have anything in common? 1, right? So I'm going to have a plus 1 there. 3x divided by 1 is 3x, plus 10 divided by 1 is 10, equals 0. We'll factor out what those two terms have in common, that 3x plus 10, and then we're left with x plus 1, equals 0. So then we'll set each of those equal to 0. 3x plus 10 equals 0. So x equals negative 10 thirds, just a little bit over -3, or a little bit less than -3. X plus 1 equals 0, so x equals -1. So let's go ahead and make our number line. So negative 10 thirds. Remember, that's -3 1/3. And then we also have -1 on that line. I'm sorry, my iPad keeps messing up. Okay, so I'm going to be plugging stuff in to, wish it would quit doing that. I'm going to be plugging stuff in to (3x plus 10, x plus 1). We want that to be less than 0. Cool. So if we plug in something like -4. So if we plug in -4, 3 times -4 is -12, plus 10 is -2. -4 plus 1 is -3. -2 times -3 is +6. Is that greater than or equal to 0? No, it's not. So that's not going to be part of my solution. Then we'll plug in something between negative 3 1/3 and negative 1, like maybe negative 2. Three times negative 2 is negative 6. Negative 6 plus 10 is positive 4. Negative 2 plus 1 is negative 1. 4 times negative 1 is negative 4. Is negative 4 less than 0? Absolutely it is. So that means that part in between negative 10/3 and negative 1 is going to be part of my solution. Now, I've never met a function that didn't behave where the solution is in the center or the solutions are the two ends. Every quadratic inequality that I've met has either been the two ends or the middle. I've never met one that doesn't, that has the middle and one end or something like that. But that doesn't mean it's not possible. So you're going to see me keep on plugging stuff into that other side, pretty much expecting to, like here in a moment, I have a feeling, or not a feeling, I know it's not going to have a solution on that other side, but I just want to let you know why I'm still going through and solving. Just because I haven't met that function doesn't mean that he doesn't exist. Okay, so let's plug in something bigger than negative 1, like 0. Three times 0 is 0, plus 10 is 10. 0 plus 1 is 1, and 10 times 1 is 10. Is 10 less than or equal to 0? No, it's not, so that's not going to be part of my solution. So I just want the values between negative 10/3 and negative 1. I'm going to look at my inequality sign. Since that's not or equal to, I'm using parentheses. So I'm going to have parentheses, negative 10/3 to negative 1, close with parentheses. Good deal. This one's a little bit different. So I'm going to distribute out my x. Then I'm going to bring everything to that left side. So I'm going to add 5x to both sides, and I'm going to subtract 112 from both sides. Now I'm going to start factoring. What's two numbers that multiply to negative 112 and add to positive 6 to end up being positive 14 and negative 8? So we know this is going to be x squared plus, I'm sorry, not x squared, x plus 14, x minus 8. Ooh, I should probably put an equal sign there, so that way I can use a zero product property. So we'll set each of those equal to 0. X plus 14 equals 0. So x equals negative 14. X minus 8 equals 0. So x equals positive 8. So we'll put those on our number line, negative 14, positive 8. So once again, I'm plugging into that x plus 14 times x minus 8. And we want that to be greater than 0. So let's plug in something less than negative 14, like negative 15. So we have negative 15 plus 14 is negative 1. Negative 15 minus 8 is another negative number. And negative 1 times another negative number is going to be something positive, right? Is a positive number greater than 0? Yes, it is. Oh, negative 23. So we get positive 23 over there. Good deal. Now let's plug in something between negative 14 and positive 8. The easiest thing to plug in is 0. 0 plus 14 is 14. Oopsies. 0 minus 8 is negative 8. 4 times negative 8 is going to be a negative number. Is a negative number greater than 0? No, it's not. So that's not going to be part of my solution. Then we want to plug in something to the right of positive 8. So maybe we'll plug in 10. So if we plug in 10 here, let's see, 10 plus 14 is 24. 10 minus 8 is 2. 24 times 2 is a positive number. That's 48. Is 48 greater than 0? Yes, it is. So this is going to be part of my solution as well. So to write that in interval notation, this is my actual answer. I have values starting from negative infinity until I get to negative 14. Then I'm going to look at the inequality symbol. Since he does not have an or equal to, I need to have parentheses on both negative 14 and 8. So I don't have any values between negative 14 and 8. Start back up at 8 till infinity. Put those two sets together, we need a union. All right, try this last one on your own. All right, so hopefully you got all of that stuff to one side. I always like to make sure that my x squared is positive. And then we factored to get 3x minus 1 times x minus 4. So then when we use the zero product property to solve for x, we get a third and 4. So then we'll put that in on our number line and we'll plug in 0. When we plugged in 0, we got a positive number, which is not less than 0. When we plug in something between between 1/3 and 4, we're going to get something negative, which is less than 0. And then if we plug in something bigger than 4, like 5, we'll end up with a positive number, which is not less than 0. So, hope that was nice. See you guys later.